Hey everybody. I just want to kind of review the water worksheet because it's a classic water worksheet. I did it as a student, I think a couple different times in high school and then in college a couple different times too. It's a teacher's favorite. So the first one here, obviously we talked about this last week. If it's polar and non-polar. If you count here, you'll see that there's similar amount of carbons as there is oxygens in class. I brought that up a couple times in class, but not so much out of class. But somebody asked me, is there like a go-to way to know if a molecule is polar or non-polar? And the answer is kind of tricky. Yes, but no. One of the best ways is you kind of look at a molecule and you kind of see and compare how many carbons to oxygens does it have. If it has a lot of carbons and very few oxygens, it's nonpolar. If it has a similar number, or if the polar molecules are in very important spots and they seem kind of loaded in one area, then we call it a polar molecule. So, for example, this molecule, without counting the carbons and oxygens, the polars spots are on one side here. This would start making me think automatically that this was polar, just seeing this. But we have two carbons, two oxygens. It's relatively the same number. This is a polar molecule. Now, last week you also learned that this is uh, carboxylic acid or a carboxyl, so that's polar. So you should know it's polar too. It does have a very non-polar other side, but as altogether we would consider this polar. Uh, then this backside here, this is the more famous end. I've even used this in the past as a quiz, but I'm not going to go through all of them. But I just want you guys to know that one of the biggest things is you can give more than one property may be used to explain a given phenomenon. So, for example, many substances, for example, salt, NaCl, sucrose, dissolve quickly in water. Well, that's probably just B. That's probably just that water is adhesive. It likes connecting with other polar substances. But something like C, when you pour water in a 25 milliliter graduated cylinder, a meniscus forms at the top of the water column. So water is attracted to the other object. That's B again. But to do that, water is also going to be attracted to itself to kind of pull itself up a little bit to make that meniscus. You remember in chemistry, anytime you put water in a tight space, it has a curved top to it. And then another example of that would be D. Sweating and evaporation of sweat from body surface help reduce a human's body temperature. Um, that's going to be high heat of vaporization. So it takes a lot of energy to get water to vaporize. Also, water has high specific heat, so that's connected to that. So it's D and E. But then you can also add probably C in there. It's important that water is at liquid um, state of matter and our body temperatures, or that you wouldn't be able to happen. So please be aware that there could be multiple different answers. It's just not one. Um, Also be aware that we have a quiz on this coming up here, and so I want you to feel comfortable. So if you don't feel comfortable, please, please, please contact me, and we'll make sure that you understand this concepts. Okay. I hope that was kind of helpful. Have a wonderful day.